What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. As network technologies evolve, organizations must adapt to new environments and methodologies to maintain efficient, secure, and scalable infrastructures. In the CompTIA Network Plus exam Objective 1.8, it focuses on summarizing evolving use cases for modern network environments, highlighting emerging technologies and concepts such as software-defined networking, virtual extensible local area networks, zero trust architecture, secure access, secure edge, infrastructure as a code, and IP version 6 addressing. So let's go ahead and dive into these use cases to better understand their significance in the networking landscape. All right, so let's talk about software-defined networking and software-defined wide area networks. And the first component we're going to focus on is application-aware networking. So SDN and SD-WAN, they enable application-aware networking, which allows the network to prioritize traffic based on application requirements. So for instance, critical business applications like video conferencing, they can receive higher bandwidth and lower latency compared to less critical tasks such as file downloads. And this capability, it optimizes resource allocation and improves end user experience. The next, we have what is called zero touch provisioning. And this is a feature of SDN and SD-WAN that simplifies the deployment of network devices to where administrators can configure devices remotely without manual intervention, which saves time and reduces configuration errors. And this is especially beneficial for organizations that manage large scale or geographically dispersed networks. Then we have what is called transport agnostic networks, and these allow SD-WANs to operate over any type of network transport, including MPLS, broadband, LTE, and satellite. And this flexibility ensures that organizations can utilize cost-effective and reliable transport options based on their specific needs while maintaining consistent performance. And then we have central policy management. So centralized policy management in SDN and SD-WAN, this enables administrators to define and enforce network policies from a single interface. And this reduces complexity, enhances security, and ensures uniform policy application across the network. So for example, an enterprise, they can create a global policy to restrict unauthorized access to sensitive applications, which is automatically applied to all branch locations. All right, so let's move on and talk about virtual extensible local area networks. So virtual extensible local area networks, this is a technology that extends traditional VLAN capabilities, providing scalable layer 2 segmentation over layer 3 networks. And it is widely used in modern data centers and cloud environments. And the first component of this is called the data center interconnect. So VXLANs, they facilitate data center interconnects, which enables organizations to link multiple data centers seamlessly. And this ensures that resources can be shared efficiently and provides redundancy for critical applications. So for example, a company with 2 geographically separate data centers, they can use VXLAN to create a unified environment, which enhances both performance and resilience. Then we have what is called layer 2 encapsulation. So VXLAN, it uses layer 2 encapsulation to encapsulate Ethernet frames within UDP packets. And this allows for better scalability, which supports up to 16 million unique network identifiers compared to the 4,096 identifiers, which are supported by traditional VLANs. And this scalability is essential for large enterprises and cloud service providers with extensive virtualized infrastructures. All right, so let's move on and talk about the zero trust architecture. So the zero trust architecture, this has become a cornerstone of modern network security, where it emphasizes the principle of never trust and always verify. So let's talk about the policy-based authentication. So zero trust architecture, this implements policy-based authentication where access decisions are made dynamically based on factors such as identity, device health, and location. So for instance, an employee accessing the network from an untrusted device may be required to undergo additional verification before gaining access. And then we have what is called granular authorization. So authorization within ZTA is granular, where it ensures that users and devices only access the resources they are explicitly permitted to use. And this minimizes the risk of lateral movement within the network in case of a breach. And then we have what is called least privilege access. So ZTA, this enforces the principle of least privilege, where it grants users and devices the minimum access necessary to perform their tasks. And this reduces the attack surface and limits the potential impact of a compromised account. All right, next let's talk about secure access, secure edge, and security service edge. So SASE and SSE, these are frameworks that combine networking and security services into a unified solution that is delivered by way of the cloud. And they address the challenges of securing and managing remote workforces and distributed networks. And here are some of the key benefits of SASE and SSE. So SASE, this integrates SD-WAN capabilities with security functions such as secure web gateways, firewall as a service, and zero trust network access. And SSE, which is a subset of SASE, this focuses specifically on security services without SD-WAN functionality. And by adopting SASE or SSE, organizations, they can simplify their network and security operations while ensuring consistent policy enforcement across users and devices, regardless of their location. All right, so let's move on and talk about infrastructure as code. So infrastructure as code, this is revolutionizing network management by enabling administrators to manage and provision infrastructure using code, similar to how software applications are developed. So within that, let's talk about automation. So IAC, this facilitates automation through reusable playbooks, templates, and tasks, and this reduces manual effort and ensures consistency in network configurations. So organizations, they can create standardized templates for common tasks, such as deploying virtual machines or configuring routers. Also, infrastructure as code tools, it helps detect and remediate configuration drift, ensuring that infrastructure remains compliant with organizational policies. Another thing it does is automating upgrades, which reduces downtime and minimizes the risk of human error. And also IAC, this enables dynamic inventories, which automatically update devices and resource lists based on changes in the environment. Another aspect is source control in infrastructure as code. So source control systems, they are integral to IAC, where they provide mechanisms for version control, central repositories, and collaboration amongst teams. What this does is it helps track changes to infrastructure code, making it easier to identify and revert problematic updates. It's also a single source of truth for infrastructure code, ensuring that teams work with the latest configurations. It identifies and resolves conflicts when multiple teams work on the same code base. And then teams, they can create separate branches for testing and development, which reduces the risk of introducing errors into production environments. All right, so let's quickly talk about IP version 6 addressing. So the adoption of IP version 6 addresses challenges IP version 4 address exhaustion and ensures compatibility with modern network requirements. So let's talk about mitigating address exhaustion. So IP version 6 provides an almost unlimited pool of IP addresses, eliminating the limitations of IP version 4. And this is crucial for accommodating the growth of IoT devices and other emerging technologies. And let's quickly talk about some of its compatibility requirements. So the first one is tunneling. So tunneling techniques such as 6to4 and Terado, they allow IP version 6 traffic to traverse IP version 4 networks, ensuring backwards compatibility during the transition to IP version 6. Then you have what is called dual stack and dual stack implementations. They enable devices to support both IP version 4 and IP version 6 simultaneously, which provides a seamless user experience during the migration process. And then you have what is called NAT64 and Network Address Translation 64. This facilitates communication between IP version 6 and IP version 4 devices by translating IP version 6 packets into IP version 4 packets and vice versa. All right, so to wrap all this up, the evolving use cases of modern network environments, this reflects the dynamic nature of technology and its role in addressing complex organizational challenges. And by understanding and leveraging technologies such as SDN, VXLAN, ZTA, SASE, infrastructure as code, and IP version 6, IT professionals can design networks that are more efficient, secure, and scalable. And these advancements not only enhance operational efficiency, but also position organizations to adapt to future innovations, ensuring long-term success in an ever-changing digital landscape. All right, so with all of that being said, let's do some check on learning. So which of the following best describes the primary benefit of software-defined wide area networks? Is it allows network devices to function without requiring a central controller? Is it enables centralized policy management and transparent agnostic routing? Is it eliminates the need for IP addressing and subnetting? Or is it solely relies on physical networking hardware for configuration? And the correct answer is it enables centralized policy management and transport agnostic routing. So SD-WAN, this allows organizations to centrally manage network policies while optimizing traffic routing across multiple transport types, including broadband, LTE, and MPLS. And this transport agnostic approach improves performance, enhances security, and reduces costs. Next question. Which of the following technologies is used to extend layer 2 networks across different data centers? Would this be VXLAN, SDN, SASE, or IP version 6? And the correct answer is VXLAN. So, Virtual Extensible Local Area Networks. This is a tunneling protocol that encapsulates layer 2 Ethernet frames within layer 3 UDP packets. And this allows data center interconnect functionality, which enables organizations to extend layer 2 networks over large scale environments without being restricted by VLAN limitations. And our final question, which of the following principles is a fundamental aspect of zero trust architecture? Is it implicit trust for internal network traffic? Is it least privileged access and policy-based authentication? Is it relying only on perimeter-based security controls? Or is it using static configurations without automation? And the correct answer is least privileged access and policy-based authentication. So zero trust architecture, this operates under the principle that no entity should be trusted by default, whether inside or outside the network. It enforces least privileged access and requires continuous authentication and authorization based on policies to ensure security.